the formation of Saturn's rings has always been a great source of debate, but more recently there's been some ideas or a new theory suggested that a ancient moon could be responsible for not only the ring system we see now, but also the current tilt of Saturn that we also see. So let's go back to when the planets actually first formed. So when the gas giants first formed, they should have formed with zero or very close to zero tilt. So their rotation axis is not tilted over. Now that is true for most planets. Now, when they form in this gaseous disk orbiting the very young sun, and the gravitational attraction means that you get these planets forming in the disk. And if they form in this disk along with the sun in situ like that, then you shouldn't have tilted over axes of their rotation because they should be rotating in the same plane as the sun and their orbit around in the disk as well. So they should actually form zero tilt or very close to. However, when we go and have a look at the actual rotation axes of all the planets, most of them have some tilt associated with them, some more than others. Some of them are always flipped over 180. You've got Uranus, which is almost over 90 degrees. But Saturn actually has a very significant tilt associated with it. So it's almost 26 degrees, which is more than the Earth. Whereas Jupiter, which is only a little bit bigger than Saturn, hardly has any tilt at all. So, what's caused that? Well, some of the actual tilt on some planets can be caused by giant impacts. So Uranus, for example, it's possible that's been hit, or had a giant impact at some point in its past by another planet, which has then formed the current system we see and also relates to some of its tilt. There can be internal mechanisms that can be responsible for knocking the tilt over, like for Venus, and also resonances as well. So resonances can cause a tilt in the planet's spin. So a resonance would be, an example here is you've got two planets orbiting around the sun. Now the closer a planet is to the sun or a star, it will orbit faster. So it has a shorter orbital period. So it takes less time to go around. One further out takes longer. Now at some point in some configuration, they will be a ratio of one another. So let's say that one planet orbits has an orbital period of 1, and then the next one has an orbital period of 2. So one takes twice as long to go around than the other. As they pass by each other, it will always be in the same location. So they'll always have a gravitational tug on each other at the same point, which actually is known as a resonance. So it builds up and essentially amplifies that gravitational interaction. Now, when Saturn first formed, its tilt, as we mentioned, should have been quite low. So maybe a few degrees. You've got a few moons there, and it's expected that Titan, which is its biggest moon, and a moon that has an atmosphere, one of only a handful that have an atmosphere in the solar system, was closer to Saturn. And you have this ancient moon further out, which is the one we're interested in the formation of Saturn's rings. So at this point here, Saturn didn't have any rings, but it had some moons. Now what happens here is Titan begins to migrate outward, so its orbit gets wider and it moves outward, and it gets closer to this ancient moon, so it's drifting outwards. But in the same time as that is occurring, the spin axis, the wobble of the actual spin axis of Saturn ends up in a resonance with Neptune's orbit. So a bit like a spinning top, the rotation axis wobbles around. That rotation of the axes ends up in a resonance with Neptune's orbit, which actually you get a resonance capture. And because it's a resonance, you amplify that effect and it actually knocks it over. So it knocks that axis over due to this resonance with Neptune, which is further out. So that's what gives it its initial large tilt. And this is a visual example of an orbital resonance. So the inner one is orbiting twice for one orbital period of the outside one. So you should see that they will always pass by each other at the same point each orbit. So they will go round and they will always pass by one another again. So you can see, so that is now half an orbital period of the outer one to one full orbital period of the inner one. And these are quite important for dynamics and how things actually occur. So you can see these are going to pass by the same location again, and that is known as an orbital resonance, which is similar to what's happened with Saturn and Neptune, but it's to do with the spin axis instead. So that interaction with Neptune then knocks Saturn's tilt over by 36 degrees, so a really significant tilt there. And as that is occurring, Titan is moved outwards, and this ancient moon that was further out is thrown inwards, so it's lightly gravitationally thrown in, and it gets very close to Saturn. Now it goes within the Roche limit. So the Roche limit is a distance from the planet. In this case, we're going to use a planet and a moon, but it can be a star and a planet. You've got two objects where one is significantly larger than the other. So at that Roche limit, a moon passing over it would be tidally pulled apart. Its own internal gravity couldn't hold itself together against the strong gravitational tides from the planet, and it gets pulled apart. And at that point, it ends up being scattered around in a ring structure around the planet. So we expect that this ancient moon went beyond that Roche limit for Saturn and now created this ring. So this ancient moon, which has been given the name Chrysalis, created Saturn's rings. We say it's an icy moon because we know that Saturn's rings are icy, and that would have caused that there. But it doesn't just stop there. So it caused or created the rings of Saturn, but it also gave the current tilt as well. So that sudden removal of the moon, so that moon has been removed from Saturn's system, it's now a ring instead. So it was a sudden kind of removal of the moon, and the continuous outward migration of Titan knocked Saturn out of resonance with Neptune. Now, because it was no longer in resonance, that tilt actually relaxed back a bit. So it is now just under 27 degrees. So 26.7 degrees is its tilt, which is less than it was when it was in the resonance with Neptune. It's just outside resonance now, and it's thought to be because this ancient moon there was a sudden removal of that from the system, and the constant outward migration of Titan has knocked it out of resonance with Neptune, and this is why we see the tilt of Saturn as it is right now. So thank you for watching, and if you enjoy, then check out some of the other videos.